So we're now recording the class. All right, so where we left off in chapter 8 is where we were talking about sampling, okay? And that's a big part of statistics, the design that goes along with sampling. So I'd like to share a screen with you to get us started here. Okay. I'm thinking that everybody can see this, but maybe not.
Yeah.
Okay, so the slide is titled "The Big Picture," and I think I've used this in the classroom a couple times, and this really does sort of summarize a lot of things that go along with sampling. All right. So we have to have a population for which we are going to sample from. That population is generally a very specific population so that we can make the sample representative or reflect what the population characteristics are. And you can sort of see that a population is sampled, and that process, sampling, is very, very important to this sample, and we want that sample to be random, and it's very important that this sample is random. We don't want a biased sample. We want a random sample. And the randomness is very, very important into in trying to get an inference about the population through sampling. All right, we really want to know something about the population, and the only way we can get to something that we want to know is by random sampling. Questions about that? Okay. Right. Okay, so we left off with random sampling, all right? And some of the characteristics of random sampling is that we want randomness, okay? And randomness is characterized by every object or individual that's part of the random sample has an equally likely chance of being selected, all right? So that in and of itself is defining randomness, okay? Every element has to be equally likely to be selected. All right, so in practice, we can use a random digit table. I think we went through that the last time we were talking about this. We can generate random numbers from a computer or a calculator. So we went through this this table, how to do this, and one of the things that go along with this is a random digit table. Of course, we have 0 to 9, so each digit is part of the table, and each one is equally likely to be selected. And we went through this pretty rigorously. So I'm going to try to go through the next slide quite quickly. So we did this random table and sort of got us going here. And we got our 4 selected hotels by using a random digit table. And I'd like to show you another version of this. So this is a simple random sample applet, okay? And so this is a random sample that goes along, or a random generator goes along with the textbook. And I'm going to go to that applet. Okay, so we're now looking at an applet, and it's a simple random sample generator, all right? So the population here, okay, the population
We're still
here.
looking at the PowerPoint.
Excuse me?
We still see the PowerPoint.
Oh, you don't see this? Okay. Sorry about that. Let me see if I can get it somewhere else here. How about this?
Yep, now we see it.
Thank you.
Okay, so what am I trying to impress you with? Number one, that we have a population, okay? And in this population, we have 144 numbers, all right? And we can start to think about a sample size of, say, 10. If we wanted to use that, we would take a sample. And so this generator is now generated from the population 10 random numbers. All right. You could copy this sample and put it into a clipboard. You might want to put it into Excel. You could reset, and you could change the sample size. And again, sample. And you would get, instead of 10, you would get 20 values in the sample. All right. So let me go back to where I was. Right. So this here is a data set, okay? And we sort of are looking at simple random numbers, okay? And this is coming from the applet. The population is 1 through 144. And I have 1, 2, 3, 4, 5 samples, okay? And the sample size is 10 values per sample. This is the sample size. And what I wanted to impress about you with is that these samples are very different from one another, okay? And that's why I have the average here, right here, to show you that the average of each one of the samples is quite different. So there's a lot of variability in the samples when they're generated from a population. That's to say that the sample 1 will not look like sample 2. Okay, there's a lot of variation. Now, if you were to go over here where we now have increased the sample size from 10 to 20, okay, from 10 to 20, we can go through the same exercise, doing sample 1, 2, 3, 4, 5. And if we went down to the average here, you would see that these two are variable. Okay, so that is an outcome that goes along with random samples. Questions about that? Okay, so if we were thinking about a sample and we wanted to start thinking about how that sample is going to give us some information about the population, okay, this is the purpose of this sample, is to get information from a larger population. And therefore, the process of drawing conclusions from the sample and applying it to the population is really where we're trying to go when we are sampling. So why should we rely on random sampling? Well, the first reason is that we eliminate bias. Okay, we eliminate bias by thinking that each value that could be selected has an equally likely chance of being selected across a list of available individuals. The laws of probability allow trustworthy inferences, and the laws of probability go along with a random-like approach. Okay, and I think I impressed you about the results of a random sample have a margin of error, okay? That means that there is going to be not only a value like an average, but there's going to be variation in that, that average. So that each random sample goes along with a margin of error that sort of sets the limits to the random sample and the statistic that comes from it. All right, the larger random samples give better information about the population than smaller samples. Okay, and what I just showed you in my chart is I showed you samples that were size 10 and samples that were size 20. And in this bullet here, a random sample with a size of 20 is better to get information from the population than the smaller sample of size 10. Questions about that? Okay, so let's start thinking about some other ways of sampling than just a simple random sample. There's all kinds of experimental design that will lead to different types of designs. Okay, so it's interesting that a simple random sample is as easy as slips in the paper and I'm sorry, slips of paper in a hat and drawing them out. But sometimes there is a need for sort of defining groups within our sample, okay? So one alternative to a simple random sample goes along with subgroups called strata. And this type of sample is called a stratified random sample. Now, what are strata? Anybody want to take a stab at what is a strata? Okay, so say we had 100 individuals, okay, in our sample. We might want to stratify that sample into men and women, and that would be a stratified random sample. So strata is subgroups out of the sample that we have already. So to select a stratified random sample, first classify the population into groups like women and men. You could think of it in different ways, there could be a number of different ways you might want to stratify a set of data. All right, and this is also part of a multi-staged samples. So you have a sample that is randomly selected, and then you classify that sample into strata that you want to follow up in, and that's a multi-stage sample. Questions about this? Okay, here is another sampling design, and here is the example. A commissioner wants to survey people in her district, okay? And she's looking for opinions about the law that's coming up about adoption. All right, so she decides that she's going to randomly select blocks in her district and then survey all those people that live in those selected blocks. Okay, so you could sort of see on a city street, you're going to use a block of houses, and that block was randomly selected. And once you have that block, you want to survey everyone on that block. So all of the people that live on that block is going to be surveyed. And this is called cluster sampling. Okay, so now we have stratified sampling, we have cluster sampling. These are two different experimental designs. Questions about this? All right, and a third sampling design is one reflected in this example. A manager of a restaurant wants to survey his or her customers, okay? So what he does is he sort of, every night the manager randomly chooses a number between 1, and 10, okay? And then takes that number, say it's 7, the seventh person that comes in for a meal is given the survey. And if there were another set of people coming in, you would use the 10th customer after the first 7, the 7th customer, and that person would be given a survey too. So you could see once you've sort of made the decision to use the 7th customer, then every one after that is the 10th of the one after. So it would go 7, 17, 27, and that would be the way you would randomly select in a systematic sampling design. Questions about this? Okay.
Actually, I have a quick one.
Okay, go ahead.
All right, it's just really basic. When you say like each night the manager like randomly chooses a number, what's the
Yes.
significance of that?
Say again.
What's the significance of him choosing a number? Like, what would he do with that number, and what is that number?
Okay, thank you for letting me I'll talk about it a little bit more. The significance of the number being picked is that is randomly picked. Okay, and once you have done a random event like that, i.e. going to 1 to 10, and all those numbers there are equally likely, and if it was randomly selected, then it would be the way you get randomness in the systematic sampling design. Does that make sense?
Yes and no. I still might be overthinking it because, yeah, I'm not getting the importance of it, because the most important thing to me right now is like he's giving a survey to every 10th customer.
Right.
So like each night he randomly chooses a number. What is that? I'm not understanding what the number is. Like, say he picks like 7, like what does he do with that?
Sorry.
No, it's okay. And I don't know if like we'll explain it more. I think I'm like not understanding that one line.
Okay, so here each night,
Yes.
okay, he randomly chooses a number. So this number here, this word right here is the point. Okay?
Yeah.
So that's where randomness is inserted into the sampling design.
Oh, thank you.
Okay, and then after that, it's very systematic.
Got it. Yeah, I just missed that step. Okay, thank you so much.
I probably skipped it too. Sorry.
All good.
Okay. All right. Now, what do I want to do here? Let's go out. Come back in. Excuse me. Okay, so cautions about sample surveys. So we really want to think about technology and using technology, but we want to eliminate bias. That's the point of random sampling, to eliminate bias. So this type of bias, this is under coverage bias, okay? That means when your survey is going out to people that have a specific sort of characteristic and you're not getting other people that don't have that characteristic. For example, those people that have landlines, okay, that is a telephone that has is in the house. Most younger people don't have landlines, okay? They don't have a phone in their house. They have a cell phone. So if you're using the landline to survey, then you're missing people that don't have that kind of phone in their house. All right. Non-response, all right? There could be, for example, people that don't want to participate, okay? Or they weren't there when you tried to contact them. So non-response is another way of thinking about bias. All right, so we want to eliminate these types of bias. All right, so a systematic pattern of inaccurate or incorrect responses leads to response bias. The wording of questions that are in your survey have a very, very important part of controlling bias. Many times questions are leading and lead the survey to one or another way of answering the questions. All right, so here is a historical sort of example, all right? So does everybody remember in 1936 when Franklin Roosevelt was in his first term? Of course we don't remember that. So in that election, okay, there was a candidate for the opposing party, Alf Landon. All right, he was probably the Republican, as Franklin Roosevelt was the Democrat. And the magazine, the Literary Digest, predicted that Alf Landon would beat FDR. And they even thought that the election would be very weighted toward Alf Landon winning, 57 to 43%. This Literary Digest mailed 10 million questionnaires to people drawn from list of automobiles and telephone numbers, and part of the magazine was had the survey in it, and 2.3 million people responded. Quite a very large sample size. Okay, so at the same time, a young pollster named George Gallup, and today you still hear the Gallup poll. He sampled 50,000 people and predicted that Roosevelt would win. Well, Gallup's prediction was ridiculed as being naive, and the Digest had predicted winners from 1916 in the past. And of course, the difference in sample size was one of the things that was thought of as being a strong point of the digest. So here is George Gallup. Okay, so what happened in that election? Well, what happened in that election, it wasn't that Landon won. Roosevelt won. Actually, he won 523 college election districts, and he won the popular vote by 62%. So what went wrong with the digest's predictions? What do you think?
They only accounted for automobile ownership when it was still relatively low.
Okay, that's right. Now, what was the state of what was the status of the nation when in 1936? Well, in 1936, the country was in the Great Depression, right? And those people that had cars and telephones, okay, they were very unusual, very, they were not very typical, right? And so that's what happened. So this would be a bias that goes along with the sampling process, all right? So those people that had a telephone or a car, those were luxuries. The people that were eliminated were the people that were leaning on Roosevelt to improve their livelihood. So this is a very a very interesting show of bias. Okay, so the impact of technology is is really influencing sampling these days. There's all kinds of surveys. You're usually bombarded with them, not over the phone, but maybe in social media. So for example, the landlines are being reduced, so that way of getting a survey done is not very useful these days. Web surveys, they are all over the place. Some are done well, some are not done all that well. Okay, so in the last couple minutes that we have here, let's use a question. All right, population versus a sample. So we have 45,000 pound truckload of potatoes, all right? So this is going to a potato chip factory. The company selects 150 potatoes from 5 different points of shipment. What is the fraction? If the fraction of the acceptable potatoes is high, enough in 150 set selections, the shipment will be purchased. What is the population here?
All the potatoes in the truckload.
Okay, so that's where the potatoes are coming from, and that is the population in this particular case. Thank you. All right. So what is the sample?
Do you want me to go again, or should I?
Well, if somebody else wants to chime in, I'd be happy to hear that too.
All the potatoes in the 150-pound section.
All right. Okay. So we go from 45,000 pounds to a sample of 150 pounds. All right. All right. So here is another presidential election. Ross Perot appeared on television. He wanted to get his opinions of government reform, and he was running for president. Perot did the same thing that happened in 1936, and he used TV Guide. Does anybody know what a TV Guide was? Well, the TV Guide was a weekly journal of what was on TV. And of course, they had all kinds of advertisements. And so Ross Perot put his survey in TV Guide, and he was interested in healthcare reform. What type of sampling method was this? What do you think?
B.
B. And well, it can't be simple random. It can't be stratified. It's probably not multiple staged. So the person that had the TV Guide, obviously, in his home was the volunteer that goes along with the response sample. Right? How about this one as the last one? Which of the following is not about simple random samples? Anybody want to take a stab at this? Okay, how about C? Individuals can be selected more than one time in a sample, and that is not true. Okay, so that does it for Chapter 8. Okay, I'm going to have a homework set of problems, okay, next Friday or this coming Friday. and we'll go and get into some other things. I think I'm going to teach you guys what the importance of the margin of error is. Okay, so I'm going to put some lectures together for that type of approach. Questions?
No.
Any questions? All right, I'm going to
PowerPoint on Moodle.